2.2 is talking about the slope of a graph. Okay, so we're going to begin with linear graphs, or linear functions. Okay, so do you guys remember hearing slope, that term? Okay, so slope can be described in multiple ways. It's the rise over the run. It's kind of the verb, just the verbiage for it. Well, the rise means the change in its vertical position. So the rise is the change in a triangle with kind of a thicker bar on the right is a delta symbol. It represents change in. So it's the change in y's. So the rise is the difference in their y's, or the change in the y's, and the run means the horizontal change, or the difference in the x's. And so what you wind up seeing here is a formulaic relationship between these. So if we were taking 2 points on this graph, let's call them points x1, y1, and then up here x2, y2. The change in the y's is just the difference of these two numbers. So it's a y2 minus a y1. And the change in the x's is the difference between the corresponding coordinates. So whichever one you used first, whichever y you used first, you have to use the corresponding x first as well. So x2 minus x1. So this right here, it'd be your equation for slope. And slope is designated with a lowercase m. Okay, so there's your slope equation. Now, it doesn't matter which way you write your y's. So we could have also said y1 minus y2 over the corresponding x, x1 minus x2. Again, notice whichever y you use first, you have to use its corresponding y, or its corresponding x first in the denominator. So either of those forms, it means the same thing or evaluates the same way. Okay, so let's say we took this example and we wanted to find the slope. Of a line passing through the following points. So there's two main ways here for you to find the slope. One, you can calculate it. Okay, so if you want to calculate the slope, you're just going to use this slope formula. M is equal to the difference of the y's. It doesn't matter which one you start with. So let's say I start with a negative 2 minus the other y coordinate, 2, and then divide by my x coordinate. Again, it has to be whatever the first one is. A negative 1 minus my other x coordinate, 1. So that's going to give me a negative 4 over a negative 2. And when I simplify it, I get my slope to be 2. Okay, now, like I had said, it doesn't matter which one you use first. If I had used the 2 first, so 2 minus a negative 2 over the corresponding coordinates for x, 1 minus a negative 1. When you subtract a negative, it becomes a positive. So for both of those, you get 4 over 2, which is still going to simplify and reduce down to the 2. And so it doesn't matter which way you choose for that. And now there's another way to identify a slope, and it's an easy visual way to do it. And that is if you plot your points. So if we were to plot negative 1, negative 2, and then we plot 1, 2. We could also use the rise over run method of plotting, or of finding the slope, and that's just to count it. So when you go from one point to the other, so from this point, from left to right, I go up how many units? 1, 2, 3, 4. So I go up 4, and then I go over how many units? 1, 2, in the positive direction. So you wind up with a rise of +4, a run of +2, and what does that simplify to? 2. So you can do it that way as well. It doesn't matter, whatever works for you. whatever you prefer. Right? If you're given small numbers that are easy to plot or graph, then definitely this way. What you're likely to see is when I give you questions like this, it'll have decimal values for your number, so you may want to calculate it.